All right, everybody, a quick look at what we're going to talk about here starting on page 19. It's going to tell you that, again, the same vocabulary that we've been talking about this whole time when we've been doing graph sketching is coming up again. But this time what we're going to be given is not the graph of f and not the equation for f, but now we're going to be looking at the graph of f prime. So we're going to be finding out all this same information again, but now we're going to be looking at the graph of f prime to get this information. So our definitions certainly haven't changed, but what has changed is what we're looking for on the graph to get this information. So let's go ahead and jump in and see what we've got. So the first thing we're going to talk about is, again, our critical points. And we know that critical points, again, are points where y prime is equal to 0 or it's undefined. Now, if I'm given the graph of f prime, it's really easy now to find those critical points because those are just going to be the zeros of, and I guess since this is f prime, I'll use f prime. So let's say instead of y prime here, let's put f prime just to be consistent. So these are going to be the zeros of f prime, or places where f prime has a corner, cusp, vertical tangent, or discontinuity. Okay, sorry, I squeezed that in. So now we have a pretty smooth curve here. So our critical points are just going to be the zeros of f prime. So I'm going to have negative 0.5, 0.5, 1.5, and 2.5. Okay, so that's our critical point. So now we're going to look at our maxima. And we knew before that maximum values occur where f prime changes from positive to negative. So before, when we were doing our tables, we were looking for where we changed again from positive to negative. So now if I'm looking for f prime and I want to know where it changes from positive, well, f prime is going to be positive when it's above the x-axis and negative when it's below. So what I'm really looking for here is places where f prime changes from above, whoops, there's no e on from, changes from above x to below x. So in this case, our relative maximum values, again, I'm looking for where I change from above the x-axis, where f prime is positive, to where it's below, where f prime is negative. So those are going to occur at x equals negative 0.5. I go from above to below. At 0.5, again, I'm from above to below. And then I'm also going from above to below the x-axis at x equals 2.5. Now, I know that my maxima can also occur at endpoints. So I have to consider my endpoint. At negative 1, I know f prime is positive. So my function starts out increasing. So that means that endpoint's actually going to be a minimum. If I consider my other endpoint, I know that at the end, my derivative, f prime, the slope of f, is negative. So f is decreasing. So that means I'm going to have a minimum at that end as well. So I don't have to worry about anything for my maximum value there. Now, those are all of our relative maximum values. So when we're talking about absolute maximum, we actually would need to know the y values of these or the y coordinates of these x values, which we can't get from this graph. So I'm just going to say we cannot determine absolute min or maxes from the graph of f prime, right? Because we need the y values, and we're not going to get that from this graph. So then we can move on and talk about minima, right? And we know now that this occurs where f prime changes from negative to positive, right? And our table is where we went, f was decreasing to increasing. So really we're looking for places where f prime changes from below x to above x. So for our relative minimum, we're looking again where we change from from below to above. So the first time that's going to happen is at x equals 0. And then again at 1.5. And that's it for the interior points. But again, we want to consider those endpoints. And again, if I go back to -1, our function f starts off increasing. So it means that endpoint was a relative minimum. So we actually have one at -1. And then again, if I look at the other end at 3, I know my derivative is negative. So my function ends up decreasing. So at that endpoint 3, I'm also going to have a relative minimum. And again, absolutes we cannot determine from the graph of y prime. Right, because we need the y values. So now the next thing we're going to look at is intervals of increasing and decreasing. Right, so for increasing, we said this is where y prime, or I'm going to use f prime to stay consistent, is greater than or equal to, 0. And so now if this is my graph of f prime, I know I'm greater than 0 wherever I'm above the x-axis. So this is our intervals of increasing, our intervals where f prime is above the x-axis. And again, we know we have closed intervals. That hasn't changed. So if I look where I'm above, I'm going to be from -1 to -0.5. I'm above again from 0 to 0.5. And then I'm above from 1.5 to 2.5. Again, that's where I'm increasing. So now decreasing is where f prime is less than or equal to 0. So I'm looking for intervals, and those are going to be closed. And now I'm looking for where f prime is below the x-axis. So I am going to be decreasing wherever I'm below. So from -0.5 to 0, from 0.5 to 1.5, and then lastly from 2.5 to 3. So just like before, the last piece we have here is our concavity. So I'm going to turn the page. And we're going to talk about where we're concave up and concave down. Again, concave up now is where my second derivative is greater than 0. So now if I'm looking at the graph of the first derivative, I'm really talking about the slope of my first derivative. So second derivative is going to be greater than 0 wherever the slope of f prime is positive. So now I'm going to be concave up, again, wherever the slope of f prime is positive. So it looks like here, and it's a little hard, we'll kind of have to estimate here, maybe from negative 0.3 to, we're positive it looks like, to 0.3. Then we're going to be positive again here over this interval. So maybe 1.1 up to 2. And those are going to be where I'm concave up. So again, wherever that slope is positive. So I'll put those in green here. Now, I'll be concave down, right? We know that's where our second derivative is less than 0. So it's going to be where the slope of f prime is negative. So now I'm negative over this interval here. So concave down from negative 1 to negative 0.3. I'm concave down, have that negative slope again right here. So from 0.3 to about 1.1. And again, the exact values aren't important as long as you have the right general range. And then again, my slope is going to be negative now from 2 to 3. So then my points of inflection are points where the slope of f prime changes sign. So either from negative to positive or positive to negative. So for my points, I'm going to abbreviate here, points of inflection, I change from negative to positive at negative 0.3. I change from positive to negative at about 0.3. Change from negative to positive again at about 1.1. And then from positive to negative at x equals 2. Okay, so for the last part of the video then, we're going to look at what some of these questions might look like here. So you're going to be given the graph of f prime and then asked a bunch of questions about the graph. So here we go. So the first thing they're going to ask you is about extrema, so listing them and classifying them. So the first thing let's look out for is our relative max values. And again, just to remind ourselves, these are points where f prime changes from positive to negative, or really from above the x-axis to below the x-axis. So I'm looking for where I change from positive to negative. So the first one I see is at x equals negative 4. I change from positive to negative. And then again over here at positive 4, I change from positive to negative. So those are my max values. And since I'm on an open interval here, I don't have to worry about endpoints. So then the next thing I want to look for is our relative minimum values. And again, this is where f prime changes from negative to positive, or in this case, from below to above. And so for us, from below to above is going to happen at x equals 0. Now, intervals of increasing. We said we're increasing where f prime is greater than 0. So that means we're looking for where f prime is above the x-axis. So we're going to be from negative infinity to -4. We're above the x-axis. And then I'm above again from 0 to 4. Decreasing is going to be the opposite. It's where f prime is less than or equal to 0, so f prime is below x. So I am going to be below x from -4 to 0, and then again from 4 to infinity. My points of inflection are going to be where my second derivative, so the derivative of f prime, is equal to 0 or undefined, and the slope changes. So here I can say I have a horizontal tangent at -2, and that slope changes from negative to positive. So I'm going to have -2, and then again up at 2. For concave up, I'm looking where the slope of f prime is positive, and that's going to happen for us from -2 to 2. And then for concave down, we're looking out for where the slope of f prime is negative. And that's going to happen from -infinity to -2, and then again from 2 to infinity. Okay, so for right now, that's everything that you're going to need to know about analyzing the graph of f prime. Tomorrow we'll get some practice with this, and we'll really be able to get into some AP questions, start looking at some FRQs to dig into this a little bit more.